Moving along, this is section 10.5. Age at maturity is influenced by patterns of age-specific mortality, which is word freaking soup. So let's think about what this means for a second. Age at maturity. What does maturity mean? Age at maturity means how old are you when you go from pre-reproductive to reproductive? What we're talking about here is, in essence, maturity is when you are able to start having offspring. Okay, maturity is how old are you when you can start having kids. Okay? Age at maturity is influenced by patterns of age-specific mortality. What this means is how old are you when you can start having kids is going to be determined by how old is your population when you die, more or less. So how old are you when you are able to start having kids, determined directly by how old are you when you die. And we're going to go into some of the details of this, and it should make some intuitive sense to you. But some organisms reproduce early in their life cycle, while others grow and develop before reproduction. When should an organism begin to reproduce? And again, this is largely going to be determined by when you die, generally, in your population. So if natural selection maximizes individual relative fitness, then the age and size at first reproduction are optimal when the benefits outweigh the cost. Sorry, I didn't mean to make that word soup, like I didn't mean to do what the book is doing. But natural selection is basically going to cause you to reproduce at the time when you are the most successful and when your offspring are the most successful. And we're going to look at a few examples of this and see why this is very obviously true. Age-specific mortality, or at what age are you dying in your cohort, is also important because it is related to age-specific expenditure on reproductive effort, or it's related to how much effort, how old are you when you die is related to how much effort you are putting into having offspring. That second point, probably less important, but we'll talk about both. So age of maturity represents the transition from juvenile to adult, or again, the age of first reproduction. How old are you when you can possibly start first having offspring? Natural selection favors individuals who age at first reproduction results in the greatest number of offspring over a lifetime. So again, you can potentially reproduce when you're very, very, very young, but if that's going to prevent you from being able to successfully have or take care of offspring later on in your life, then that's not what's going to be optimized by natural selection. So in the example we're going to look at, we're going to assume that once an individual matures, it is going to reproduce repeatedly, and it's going to reproduce every cycle that it possibly can. We're also going to assume that individuals vary in what age they are maturing, or else this experiment wouldn't really make very much sense. Then we're going to assume that once an individual reaches maturity, it's not going to grow anymore. So basically what we're saying is if the best time for you to have kids is, in the 20th generation or the 20th time period, it's not like it's going to be better for you to have kids if you wait until 25. So we're saying once an individual reaches maturity, it stops growing. We're also saying fecundity. This word fecundity basically just means the number of offspring that you have. So the number of offspring that you have increases with body weight. So sort of the heavier you are, the more offspring you are able to have. Okay, you increase your development, you're able to have more offspring. A female that begins to reproduce at age 3 will have 10 offspring per year. A female that waits until she is age 5 is going to have 15 offspring per year. That's the hypothetical world that we're living in this example, okay? So if you start having kids at 3, you have 10 a year. If you wait until you're more developed, until you're bigger, you're going to have 15 a year. Females that delay maturity by those 2 years will have a greater total number of offspring if they live to be age 12. So let's look at the chart here. So you can see that the reproductive rate for these females that waited overtakes the females that started having offspring earlier, right about here. And if you increase this out to age 12, um, it actually overtakes. So at age 12, these purple individuals actually have more offspring than, or I'm sorry, these yellow individuals have more offspring than these purple individuals. So what if the female does not survive to age 12? Because again, at age 12, that is when these orange or yellow ones have more offspring total. What if they never reach that point? Well, then I'll let you think about it for a second. Pause the video or whatever you want to do. But if and this if this organism does not live to be age 12, then natural selection isn't going to favor it, right? Because it's not going to have as many offspring as this female that started reproducing earlier. So that's basically what's happening here. So this particular trade-off only makes sense. This trade-off only makes sense if this female that waited lives to be older than age 12. That's the only time that it makes sense. So we're going to be looking at one more example. What is the benefit of delaying maturity and what is the cost of delaying maturity? And we can think about those before we start thinking about examples. The benefit of delaying maturity is that you get larger, you get bigger, you are more well ready to take care of that offspring. You are more developed. The cost of delaying maturity is that you can potentially die before you can have kids, before you can have offspring. All right, so obviously the sooner you start, the more likely you are to have offspring before you die. But if you wait, you might get bigger and you might have a better chance of having more offspring that are actually successful and can continue to pass your genes on to the next generation. So again, delaying maturity, larger body size at first reproduction, that means that you have an increased fecundity, you have more offspring. The cost of delaying maturity is that you can die before you actually get the opportunity to reproduce. Younger age of maturity is favored if adults have low survival rates. So if everyone in your cohort, everyone in your population is dying before they reach sexual maturity, before they're able to have offspring, a younger age of maturity is going to be favored for sure. Older age of maturity is favored if juveniles have a lower survival rate relative to adults. Okay. Many studies support this. In fact, we're going to think about some guppies in Trinidad. It's a local population that vary according to their life. They vary in their life history characteristics. And the reason that they vary is because of the predators where they live. So this is the same species, a couple of different populations. And in one of these populations, their main predator are these cichlids. Okay. Cichlids are eating the larger, they're eating sexually mature guppies, and so the guppies are maturing earlier because if they wait until they get big, they get eaten by cichlids. In killifish, which eat the sexually immature guppies, they're eating the smaller guppies, those individuals, those populations are waiting until later on in life. Okay, and this should make some sense to you. If you wait until you're large to reproduce, but then you just get eaten by a cichlid, why wait? It doesn't make any sense. If you're going to get eaten when you're small anyway, you might as well wait and mature later on in your life. So basically what they did is they took guppies from a place where there was a bunch of cichlids as predators, and they were moved to a site where there were killifish, but there were no existing population of guppies there. Okay. Took some guppies where they were eaten when they were older, and they put them in a place when they were eaten when they were younger. Came back, not just 11 years later, they actually sampled them repeatedly. But at the end of 11 years, the age of maturity had increased. Okay. Female size at age of maturity had increased. They're getting bigger. before they're having offspring. And fewer offspring are actually being produced. Okay, so this is an actual experiment that they actually did that really helps. This is not some theoretical, not theoretical is a bad word. This is not some hypothetical situation where some ecologist said, oh, this seems like a good idea. They've actually tested this in nature. So the next topic that we're going to talk about is reproductive effort. This is again governed by trade-offs between fecundity, or the number of offspring that you have, and survival. So that'll be our next video.